And welcome everybody to another exciting lesson with me, Mr. Dreger. We're learning about significant digits today for your grade 11 chemistry course. That music was added for a few of those there. I'm not going to say names who said my lessons were not exciting enough. So that music was for you to increase the excitement. So today what we're doing is we're learning about significant digits. Particularly, we're learning how to use them in calculations. Success criteria is a fancy word that teachers are using nowadays. It's pretty popular, but it breaks down the learning goal into specific things that you're going to be able to do. The first thing that you're going to be able to do is determine what digits are significant, and you're going to figure out how to use significant digits in addition and subtraction, and finally using significant digits in multiplication and division. So what are significant digits? Well, the digits are basically they're the digits that we record on a piece of paper when we measure something. These are called significant digits. It's not going to really make a lot of sense until I show you an example. But they contribute to something called the precision of our answers. So take a look at this exciting example right here. What you have is a leaf and you have a ruler. Now, how would you measure this? Take a moment and think about what number you would record for the measurement of this leaf. Well, the question that I have for you is how many people said the answer should be 3.5? Well, in truth, we really only can be, we only can really consider this digit as being significant. This one here is more of a guess because we don't really have a measurement here. So really the term here, as confusing as this seems, this really only has one significant digit because we can only be certain about the 3. The 5 itself is actually considered an estimate. So basically, the answer is only as precise as the tool that we're using. In this case, it's not a very precise ruler. So we can't really consider this as a digit that we could include, as strange as it sounds. So let's summarize some rules for finding significant digits. The first rule that we have is that all non-zero numbers are significant. The number 3.14 has no zeros in it, so therefore it has 3 sig digits, so 3 significant digits. The second rule that we have is that all zeros between non-zero numbers are significant. Let's take a look at an example. This here is a 0 between two non-zero numbers, so therefore it's significant. And these are non-zero numbers, so they are significant as well. So therefore, this has 3 significant digits. Beautiful writing. Now here's where it gets a little bit tricky. Zeros located to the left of a non-zero number are not significant. Let's look at an example. 0.0035 only has 2 significant digits. And the reason is because this is a non-zero number. These are zeros located to the left of them. So therefore, these values that I've underlined are not significant. And these two values here are the only significant digits. So therefore, we have 2 sig digits. This last rule is my least favorite rule and probably the most confusing. Zeros located to the right of a non-zero number may or may not be significant. Let me give you an example. If I say to you that I make $30,000 a year, generally I don't give you the exact amount that I make. So therefore, these values here are generally not significant if I'm giving a rough estimate of how much money I make. Now if I say I make $33,129, if I tell you my exact amount of money I make, then that means I have 5 significant digits because I'm not giving you an estimate of how much I make. So when I say estimates, that can kind of mess you up. So if I ever give you a number, I want you to assume that I don't give you any estimates in class. But let's say that you came across an answer like this in one of your calculations, but you only can include one significant digit. Well, the answer to do that is to use scientific notation. And scientific notation, if I'm going to turn this into scientific notation, I want to put my decimal place here. Well, there's 4 zeros after that, so it would the decimal place would have to move 1, 2, 3, 4. Well, in that case, what we would do is actually, we just write 3 times 10 to the 4. And that only has one significant digit. Scientific notation is a way of writing these estimates. We'll talk about it tomorrow in class to make sure that we're clear on this. So let's talk about our rules for calculations with significant digits. The first rule that we have is for multiplying and dividing. And the answer, what we have to do there is the value with the fewest significant digits determines the amount of significant digits in our answer. Let's look at an example. In this question, what we have is we have two numbers. If we look at it, we have to count the amount of significant digits. Here we have two non-zero numbers, so that has 2. And here we have 4 non-zero numbers, so that is 4 significant digits. So therefore, our answer should have 2 significant digits. What I would do is just calculate quickly in my calculator, and then I'm going to round my answer so I have 2 significant digits. Now this is the answer that I get in my calculator, but I only can have 2 significant digits. So that means I have to round to these 2 numbers. In this case, that means I have to eliminate all of this, and we can just round down, and our answer is 29. So we can only be as precise as our least precise measurement, which only has 2 significant digits. So our answer must have 2 significant digits as well. As odd as this seems, this is the best way to calculate problems. Including as many decimal places as possible is technically not correct when you're doing your work. So the same thing applies when we're dividing and multiplying, and we're doing more complicated things than that. You have to include your answer to have the least significant digits as what goes into the question. If we're looking at adding and subtracting, the value with the fewest decimal places determines the number in your answer. This is a little bit different than multiplying and dividing. Let me show you some examples. If we're going to look at this question here, we are technically, again, not looking at the amount of significant digits. We're looking at the amount of decimal places. This has 1 decimal place. This has 3. This also has 3. So when we answer it, what we have to do is make sure that our answer only has 1 decimal place. So when I add this up in my calculator, I get 20.086. I can only have 1 decimal place in my answer. So therefore, I'm going to take this and round it to 20.1, and that's my answer. The same thing happens when I do subtraction as well. The last part here is a rule about rounding that is going to seem very strange to you. And it even seems strange to me. And to be honest with you, it rarely comes to play when we round things. The reason we do this is to keep, generally when you had 5, you'd normally just round up. But to keep things even, we round up half the time with 5, and sometimes we round up the other half down. So let's just read the rule. If your number ends with a number greater than 5, round the preceding number up. Well, let's take a look. This here, if we're going to round this number is greater than 5. So therefore my answer is going to be 18.7. That's pretty easy. If the number ends less than 5, round down. Well, our number here is less than 5, so therefore we're going to round this number down just to 17.3. Now here's where the strange thing happens. If the number ends in 5, round up if the number is odd. So let's take a look at this. This here is a number that is odd. This is a 5. So what it's saying is that we are going to round up. So the answer would be 45.8. If we look at this number here though, if the number ends in 5, round down if it's even. So because this number here is even, what we're going to do is round down. 45.8. So both of these numbers round to the same number, despite the fact because of this rule. Now, we're not going to focus on this rule too much, so I don't want you to lose sleep over it, but it is technically on the worksheet that you're working on in class, it is important that you follow these rules. Okay, thanks so much. I'm going to end the podcast now. I hope you enjoyed that and that wasn't too long. Enjoy your night.